All right. So today's topic is area of triangles. Now you have used one of the formula for the area of a triangle for a right angle triangle, and that was half times base times height. So if you have a right angle triangle and if you know the base and you know the perpendicular height, then you can use this formula to calculate the entire area of this triangle. But that mostly you have used this in when you have a right angle triangle. Now, if you don't have a right angle triangle, for example, something like this, but still you have the base, the entire base of the triangle and the perpendicular height, then even then you can use the same formula to calculate the area. If you know the base and you know the perpendicular height, this if the question says that this is a perpendicular height of the triangle, then you can just use this formula half times base into height. You are going to take the entire base and times by height. Now what do you do if you have been given a non right angle triangle? Non right angle triangle with two given sides, let's say A and B, and you have been given uh, this angle. So to find the area of such triangles, we have a new formula, and that formula for finding the area of the triangle is half times the product of AB sine of angle C. So basically, if this was point A, this is point B, and this is point C in a triangle, the side opposite to point A is small a, is denoted as small a. The side opposite to the length to this angle B is small b, and the side opposite to this angle C is small c. But if you have two sides and an inclusive angle, you can just use this formula to find the area of the triangle. Now, if you are using these two sides, then the angle you are going to use is angle C, half times the length opposite to the A angle, the length opposite to the angle B, and the angle C, sine of angle C. Now, if you can also use this length and this length, but then you will have to use angle A. So if I rewrite the formula, I can also write half times BC sine of angle A. Okay, and if you are given, let's say, this side and this side AB, okay, so the area for the area you will have to use this angle B then. So you can write half AC times sine of angle B. Like, there are numerous ways of getting this same area. Okay, the area still is going to be same no matter what formula you use, because we are talking about the same triangle. Okay, so you just need to remember that in this case, two sides and an included two sides and included angle is given. So the angle should be between the two sides to find the area. Okay, any questions still here?
No, sir.
So let's solve a question. Let's say I'm giving you a triangle PQR PQR, and the length of PQ is, let's say, 32 centimeter, the angle is 30 degree, and the length of the entire QR is 43 centimeter. I want to ask you, what is going to be the perpendicular height from P to QR? You need to calculate the perpendicular height. The question wording should be calculate the perpendicular height from P to QR. Okay, so think for a minute and let me know what do you think should be the first step. So first of all, you're going to find the area of triangle PQR. Now, which formula would you be using for area of the triangle PQR? Half times 32 times 43 times sine of 30. You have been given two sides and an inclusive angle. This will give you the total area of the triangle PQR. ठीक है? Now, would you agree that the area would still be the same if you would have used the other formula that was dealing with the height? Half times base is 43. So if I write half times base of this triangle is 43 and height is unknown, will I be getting the same area? Would you agree with that? चाहे मैं एरिया का ये फॉर्मूला यूज करूं या ये फॉर्मूला यूज करूं, इट्स द सेम
G.
ट्रायंगल, सो एरिया तो वही आएगा
Yes.
ना. So I'm going to equate this expression to half times 32 times 43 times sine 30. You can simplify whatever is possible, and h is going to come out as 32 times 43 times sine 30 upon 43. So 43 cancel, 32 times sine of 30 degree. Sine of 30 degree is 1 upon 2. In the last class, we did sine of 30 degree के ratio. Sine 30 degree was 1 upon 2. So 32 times 1 upon 2 is 16. 16 centimeter square. 16 centimeter is the height of this perpendicular height. Okay.
Okay.
Any questions till here?
No, sir.
If you get question like this, would you be able to do now?
Yes.
All right. Now, next we are going to discuss the concept of sine rule. Now, sine rule is basically derived from the concept of the area of the triangle. Consider this triangle ABC. This length is going to be small a. The side opposite to angle B is going to is going to be denoted as small b, and the side opposite to angle C is going to be can be written as small c. Now, if I ask you to find me the area using angle C and the side A and the side B, what is going to be the formula for the area? Just apply the formula for the area. What was the formula for the area of the triangle? Half times
Base into height.
but that was when you were given the base and the perpendicular height. Now if you have two sides and an inclusive angle, which formula would you use?
AB into sine theta.
Half times ab
Half times AB
into
into sine
sine
theta.
theta. In this case, theta is going to be angle c, because
Yes.
that is the included angle between the two lengths. Now would you agree that the formula for the area, the area is still going to be the same if I would have used ang- side a, side c, and angle b? So
Yes.
if I want to write down the area expression, area formula using these three terms, the two sides A and C and angle B, what is going to be the formula? Half times A times C times angle sine B. Half times A C sine of angle B. Is that correct?
Yes.
Now can you tell me how would you be finding the area if you were given the side B, the side C, and the angle A? What would have been the formula for the area?
Half BC into sine A.
Half BC into sine of angle A. Okay. Now these three represents the area, so they must be equal. Okay. So if it's an equation and if you simplify this, I can get rid of the 2's in the denominator because they are present on all the sides of the equation. You get AB sine of angle C. I'm just doing the derivation of the sine rule. AC sine of angle B equals to BC sine of angle A. Now, what you are going to do is you are going to divide all of these terms by ABC. To, to get the sine rule, you can divide by the product of all the sides. So, what you can observe now after dividing is that A and A is going to be cancelled, B and B is going to be cancelled. So, I'm going to get sine of angle C upon C. A and A cancel, C and C cancel. So sine of angle B upon B. B and B cancel, C and C cancel. So sine of angle A upon A. And they all are equal. This is what we call the sine rule. In the sine rule, the ratio of the sine of the angle upon to the opposite side is equal to the ratio of sine of the other angle upon the opposite side of that angle. For example, if if you have sine of angle C, if you take sine of angle C upon C ka ratio, that is going to be equal to sine of angle B upon B. That is going to be equal to sine of angle A upon A. And this rule is known as the sine rule. So for your now you can just remember this rule for the working. Now either you can write this, or you can also reciprocate this equation. You can write C upon sine of angle C b is equals to B upon sine of angle B equals to A upon sine of angle A. Whichever way you're convenient to use the sine rule. But this is the sine rule. Now why do we use sine rule? We are able to apply sine rule basically to solve for all the unknown angles and sides of a triangle. Now there could be two situations. So why do we use sine rule? We use sine rule to solve for all the unknown angles and sides. There could be two situations. Now you can use sine rule when you are given two angles and one side. If you're given two angles and one side, okay, अगर दो एंगल्स आपको पता है तो आपको तीसरा एंगल भी पता होगा. इज दैट ट्रू? अगर
Yes.
ट्रायंगल के दो एंगल्स पता है तो यू ऑलरेडी नो द थर्ड एंगल एज वेल. सो
Yes, हम
यू नो
180
द
से
थर्ड
माइनस
एंगल.
कर सकते हैं ना.
बिल्कुल सही है. सो यू नो द थर्ड एंगल एज वेल. सो इस सिचुएशन में या तो आप यूज कर सकते हो. ठीक है, अब इसकी एक एग्जांपल देख लेते हैं फौरन. लेट्स से in triangle ABC, angle A given to you is 72.3 degrees, angle B given to you is 50.5 degrees, and C is given to you as 5.6 centimeter. तो अगर ये information given है and you need to solve the triangle, meaning you need to find the unknown sides. So let me draw this triangle. I'm just drawing a random triangle right now. Triangle ABC. Angle A is 72.3, angle B is 50.5, and the length C, small c है ये, ठीक है. So the length C denotes the length opposite to angle C, and that comes out to be 5.6 centimeter. How can I use the sine rule to calculate the missing lengths and the angle? So what the quantities that are unknown, I'm going to write it with this color. This is going to be the length B, this is going to be the length A, and this angle C is also unknown to us. So we need to find the length A, small a, the length small b, and the angle C. तो सबसे पहले एंगल C ढूंढ लेते हैं, ठीक है. एंगल C नवाल कैसे ढूंढ सकते हैं?
180 से माइनस कर देंगे.
So for angle C, you can subtract the sum of 72.3 and 50.5 from 180.
57.2.
Okay, so 57.2 degree is the answer for the angle C. Now is the time that you apply sine rule, because you have the angles, you have all the angles now. So if I want to apply sine rule, I know this angle now, 57.2. I have this angle and I do have the side opposite to this. If I want to find B, I do have the angle opposite to it. So if I use the sine rule, I can use sine of angle C upon 5.6, the length opposite to, let me write down the sine rule first. Sine of angle C upon C is going to be equal to sine of angle B upon B. So sine of angle C is 57.2. The side opposite to this angle 57.2 is 5.6 centimeter. The ratio is going to be equal to sine of angle B, which is 50.5, sine of 50.5 upon the length B. Now please make sure your calculator is in the right mode, degree mode, before solving this equation, and you're going to cross multiply and solve this equation. So what is the value of B coming out?
8.15.
प्लीज वापस से कैलकुलेशन करें. 5.6
Okay.
multiply by sine of 50.5 divided by sine of 57.2.
5.14.
5.14. Good. So you're going to give your answer to three significant figure, 5.14 centimeter. Now, can you do the same thing to find the length of A, small a?
Yes.
How? So tell me, how are you going to apply the sine rule to find the length of A?
Can I solve it?
You can share your thought with me. सबसे पहले क्या करना पड़ेगा? You're going to take sine of,
साइन बी ले सकते हैं या फिर साइन सी भी ले सकते हैं सर।
सही है। सो बेहतर है साइन सी ले ले। चलो साइन सी से बताओ मुझे।
साइन सी अपॉन सी
यस,
इज इक्वल्स टू साइन ए
साइन ए ओवर ए
अपॉन स्मॉल ए। यस।
अपॉन स्मॉल ए, राइट। So sine of 57.2 upon
5.6
5.6 must be equal to sine of angle 72.3 upon
अपॉन
the
ए।
length A. Cross multiply and get me the value of A.
6.35।
6.35. Okay, that's correct. 6.35 centimeter. Yeah, good. So now you understand you could be asked to use the sine rule when two angles and one side are given, and the other, if you were asked to find any other length, you can use this. Okay.
ओके।
Okay. Let's move on to the second situation when you could be asked to use sine rule. When two sides and one non-included angle is given. When two sides and a non-inclusive angle is given, meaning ABC triangle, two sides, let's say you are given this side, you're given this side, two sides, but you're given this angle. Okay, so two sides and a non-inclusive angle is given. Now that is the second situation. Now before diving into this second situation, let us discuss, like, you know that sometimes, if just a second, this is the perpendicular height of the triangle. This is, let's say, the length A, this is angle B, and this is angle theta. Now, if you want to form a triangle, your length A must always be greater than the length of the perpendicular height. Otherwise, you will never get a triangle. Can you visualize this? If I have the length A, if I somehow make the length of A smaller than the perpendicular height of the triangle is not going to be completed. So, सही है? For example, if A and
जी सर।
H are equal, if the length of A and H would have been equal, then you will not get a triangle. For a triangle to be formed, the length of A, the length of this side must be greater than the perpendicular height. Then only this is going to be completed and you are going to get a triangle. Okay. So let's say this is the case where the length of A is greater than the perpendicular height. The triangle is formed. Now, if okay, I'm gonna do this over here. If in your triangle, the length opposite to the given angle is greater than this side, you're only going to have one solution. So if the length of A is greater than the length of B, meaning the other side, then we are only going to have the possibility that there is only going to be one triangle being formed. There is only one triangle is going to be formed. Okay, you can do this using construction, that if the length opposite to the given angle is greater than the other side, there's a possibility of only one triangle. However, if if the length A, acha, coming back to this, you if you are asked to solve this triangle, you can use sine rule. Okay, how can you, let's say if you are asked to find this angle B. Nawal, would you agree that to find angle B, I'll have to use sine rule? I'm going to use sine of angle A upon A is equals to sine of angle B upon B. ये बात ठीक है?
जी सर।
तो मैं एंगल बी फाइंड कर सकता हूँ, ठीक है? इसमें मुझे एंगल बी, आई वाज ट्राइंग टू फाइंड एंगल बी व्हेन the length A, B, and this, when two sides and a non-inclusive angle was given. So in this case, you can apply the sine rule, and only one triangle is going to be formed. So the second situation was that if you have two sides and a non-inclusive angle given, and if you are asked to solve a triangle, there is only going to be one triangle. So there is only going to be one solution for angle B and for this third length, this third unknown length. So the idea is that if the length of A, the side opposite to the given angle, was greater than the other side, then we are only going to be having one triangle, which means one solution. Only one solution for angle B, one solution of angle C, and one solution for the length C. Only one triangle is going to be formed. Now let's discuss the situation in which the side opposite to the given angle becomes less than the other side. So again, I am being given two sides and a non-inclusive angle, but this time the side given is less than the other side. So if this length, the side given opposite to the side opposite to the given angle is less than the other side, then we have a case known as the ambiguous case. In ambiguous case, there is a possibility of two triangles being formed. Two triangles are going to be formed. Hence, there are going to be two solutions. Now, how is this done? Let me show you. You can have one of the triangle You can have one of this triangle having the same length A, the length B, and the angle A, and the other triangle is going to be formed like this. I can have another length A over here. Okay, so what I'm trying to say is that there is a possibility of having another triangle having the same dimensions of A, B, and angle A. So the length A, B, and angle A stays the same, which means that I can construct two triangles having these dimensions. एक तो ये yellow area हो, yellow triangle हो सकता है, in which I have this angle A, this length B, and this length A, and the other triangle that could be formed is the outer one, in which I can have this as my length A, this as the length B, and the same angle A. So the values of A, B, and A are same. The only thing is over here is that when the length opposite to the given angle is less than the other given side, then there is a this is called an ambiguous case, in which there is a possibility that two triangles can be formed. So two triangles means there could be two solutions. So if I label my triangle A, B, C, I can have another triangle A, B dash, C, because this point could either be here or could be here. That's why two triangles can be formed. So again, the side opposite to the angle B is going to be this of the same length. Over here, the angle is going to be different. Angle B will have two solutions, and angle C will have two solutions. Angle C will have two solutions, and the side C will have two solutions. So this case, ambiguous case, arises two when you are given two sides and a non-inclusive angle. So let's do ambiguous case again over here. Ambiguous case. So the first condition for the ambiguous case is that two sides and non-inclusive angle is given. I can draw the triangle again. ABC. This is given to us, this is given to us, and this angle A is given to us. So I'm gonna highlight them, that these are the things that are given to us. Now whenever two sides and a non-inclusive angle is given, there could be a possibility of an ambiguous case. Now how do you check whether the case is ambiguous or not? Your if the side opposite to the given angle is less than the other side. Before this, there's one another condition, and that is that the angle given should be acute. It should be an acute angle. So angle given should be acute. Two sides and a non-inclusive angle is given. The angle should be acute, and the side opposite should be less than the other side. If these three conditions are fulfilled, then there is an ambiguous case. So if you can see in this figure that length A is smaller than the length B, and this angle is acute, so hence we have an ambiguous case. If we have an ambiguous case, then we can form two triangles. The same length A could also be drawn over here, and this means that the same point B could also be over here. So for the new location of point B, I'm going to write B dash. Okay, so there are these are the two possibilities. Now, okay, if you consider the outer triangle, Nawal, how should I find angle B? If let's say I want to find angle B, what should I do? The length of A is given to me. The length, so I'm going to use this length. The length of A is given to me. The length of B is given, and the angle A is given. How do you think we should find angle B?
Sine rule
Sine rule. Very good. So if I use sine rule, sine of angle B upon
upon
the
B,
length B should be equal to sine of angle A
sine
upon A.
upon A.
Sine of angle A is given to me. The length opposite to angle A is also given to me. The length B is also given to me. So I can find angle B from here, right? I can easily find angle B. Now,
Yes,
so if I have angle B, can I also find angle C? In this triangle,
yes,
I have angle A, I have angle B, I can easily find angle C. Okay, great.
yes,
मैं दोनों एंगल्स को ऐड करके 180 से सब्ट्रैक्ट कर दूंगा. Once I have the angle C as well, can I find the length opposite to the angle C using the sine rule again? Is that possible?
yes,
So
yes,
I can find the length C as well. All right. So this is just one solution. Now, as we discussed that it's an ambiguous case, there is a possibility of having two solutions. So point B could either be over here or could be over here. So that means that angle B should have another value as well, for which we can have the same sine. And if you remember that sine of an acute angle was equals to sine of the obtuse angle. So in the last class, we also looked at this identity, I would say. Sine of 180 minus theta was equals to sine theta. So sine of 180 minus theta was equal to sine theta. Now, for example, if angle B would have been 60 degree, or just to take, let's take theta as 30 degree. Let's say we would have solved from here and angle B comes out to be 30 degree, for example. So would you agree that to find another angle having another obtuse angle having the same trigonometric ratio of sine, I can just use this identity. So if you take theta to be 30 degree, then sine of 30 degree must be equal to sine of 180 minus 30. And what is sine of 180 minus 30? 150. So that means that to have the same trigonometric ratio of sine, that if one of the angle is 30, the next angle is going to be 150. The obtuse angle is going to be 150. So I would say that if this angle is coming out to be 30, then the another possible solution of angle B is going to be 150, because for 150 I'm going to have the same sine key value as of sine 30 degree. So from so over here, using this concept, I can find, if I just know this angle, what I can do is to find the other solution of B dash, I can just minus angle B from 180. I'm going to get the value I'm going to get the value of this angle. So I now have the location of point B dash. Now meaning I have the angle with me. Now, if I have the angle, I can consider this triangle. I can just focus on this triangle for now. This triangle have this length as the same A, this length as B, this angle is A. I just found B dash. So considering this triangle, what is the angle C dash going to be? This angle is going to become C dash. C dash. What is angle C dash going to come out? This angle in this triangle. If I know this angle A, if I know this angle B dash, can I find this angle C dash?
Yes.
So I can just add the two and subtract it from 180. I'm going to get this angle. Okay. So you have all the three angles now. You had angle A, you found angle B dash, and then you using those two angles you found angle C dash. Fine. Only one thing is left to solve this triangle, and that is the small length C dash. To find this length C dash, what comes to your mind? What can you do?
To find C dash,
Yes, the length C dash. Using this triangle,
sine
you have
law.
this length. बिल्कुल सही है. Sine rule, you can use sine rule. Good. So to find this, you can again use sine rule. So कैसे sine rule मैं use करूँगा? Sine of angle C dash upon C dash is going to be equal to sine of angle A upon A. So I can, from here I can find C dash. ठीक है? So do you understand the ambiguous case now?
Yes.
Should we look at a question?
Okay.
Okay. Okay, you are going to tell me if ambiguous case is possible or not in this case. This is triangle ABC again, but this time angle A is 47°, the length A is 75 centimeter, and angle B is 80 centimeter. You can take time and think if this is an ambiguous case or not. Okay, so you said it's possible that there are two triangles being formed. And how did you identify that? If you just draw,
Two sides and one inclusive angle.
yes. So if I say this triangle ABC, angle A is 47, the length A is 75, and this length is 80. So two sides and a non-inclusive angle is given. The side given is less than the opposite side and the angle is acute. So yes, there is going to be an ambiguous case. Okay. So if we have ambiguous case, then one of the possible location of angle B is going to be somewhere here, having some different angle of B dash. So we are going to name it B dash. सबसे पहले we are going to form the outer triangle. ठीक है? So we are going to find the angle B. We can find angle B by just using sine rule. Sine of 47 upon 75 is equal to sine of angle B upon 80. So please find me the angle B now.
Okay.
and then you can take sine inverse of these values to get angle B.
51.3.
51.3. Yeah. 51.3 degrees. Okay. So this is angle B, 51.3 degree. Then let's find angle C. To find angle C, I'm going to subtract the sum of 47 and 51.3 from 180 degree. Are you getting 81.7?
Yes.
Okay. So if the angle C is 81.7, then let's find the length opposite to angle C. So sine of 81.7 upon the small length C is going to be equal to sine of 47 upon 75. I can just cross multiply and find the value of the length C. Please give me that value.
101.4.
101.4. So 101.4, if I round this to three significant
101.
figures, 101 centimeter. Okay,
Yes.
good. So this is the solution. This also includes in the solution. These are the solution of the outer triangle ABC. Now let's look at A B dash C, triangle A B dash C. So to solve that part of the triangle, I should understand that if the length BC was 75, then the length B dash is also going to be 75. That's the first thing, because the dimensions are not going to change for the lengths and angles. The dimensions that were given are not going to change. Okay. So using this triangle now, acha, what did we discuss? How will we be finding the angle B dash? If we know this angle, how can we just find this angle B dash? अच्छा, इसको समझने का एक और तरीका ये था, would you consider triangle BCB dash to be an isosceles triangle? BCB dash, क्या मैं इसे isosceles triangle कह सकता हूँ?
जी.
अगर isosceles triangle में बेस एंगल्स इक्वल होते हैं, जो ये एंगल है
जी.
वही ये एंगल होगा, ये वाला एंगल क्या
हम्म.
था 51.3, तो ये एंगल भी
51.3.
51.3 होगा। तो आप मुझे ये
हम्म.
बता सकती हैं कि ये वाला एंगल फिर क्या होगा? If A, B dash and B is a straight line, then what is going to be this angle? You would simply do,
77.4.
yes, you would simply do 180 minus 51.3 128.7 आना चाहिए आपके पास. Is this what you are getting?
Oh, I was getting the wrong answer.
Okay. So you are going to find this angle by subtracting angle B 51.3 from 180. So you get 128.7. Up, you can just shift your focus on this triangle. I want to find the new angle C and the new length of C dash. So the new angle C is going to be, if I know this is 47, if I know this is 128.7, can I find this angle C now? The new value of C?
Yes.
That is
Hmm.
just going to be 180 minus the sum of 128.7 plus 47. What do you get?
4.3.
4.3. So that's 4.3 degree. Now once I have the angles, the new angle C, I can have the new length C as well using the sine rule. Sine of 4.3 upon the new length C is going to be equal to sine of 47 upon 75. You can just cross multiply and find the length of small c. What are you getting?
7.68.
7.68. What is after 8?
9.
9. So it is
7.07 हो जाएगा.
नहीं 7.69 हो जाएगा in three
Oh,
significant
okay.
figures. ठीक है,
Okay.
that is the length C. So now the other solution of the same triangle was this angle and this length. Now you understand how to do this?
Yes, sir.
Okay.